Good everyone, my name is Graphics. Today we want to look at another aspect of differentiation, which is the power rule. The power rule is just our normal differentiation, but in this case we usually focus on the power. Now let's take for instance now. If we know very well from our normal indices in algebra that if I have x to the power of n, the n here is what we call our power, right? Or you call it the exponent, right? Or you call it the index, and so on and so forth. Why the x here is the base. Now we'll be focusing more on the power. For instance, if I have y equals to x to the power of what? N. Right? If I'm to look for the derivative of this, that is if I differentiate this. Now I'm differentiating my y with respect to x. This can also be written as f of x equals to what? Xn. So this is the two way you can write this, because y is a function of x. That's why you call y to be what? F of x, right? Now, if I'm to differentiate this, I'm differentiating y with respect to what? X. So it will be the y all over the x. Once I've done this, it means that what? I am looking for what we call the gradient. Differentiation means you are dealing with slope gradient, right? So I'll write it this way by saying x raised to power n. Once I've done this, means that the n must come down. Means whatever is up must come down. Once I've do it this way. Now this will now give me n. Then I'll subtract 1. Once n come down, once the power come down, you subtract 1 from the power. So this is our general formula for what? For differentiation. Similarly, if it's for this, I told you these two are the same. Either you write it this way or you write it this way. Now, how would another way for writing my dy over the x is like what? I'm going to put my f of x, right? Then I'll put prime on top to show that what I am already differentiating, and I'll be having the same thing, which is what? This guy here. So it is the same. So whether you see this or you see this, we are all saying the same thing. And sometimes you might get confused. They might tell you, okay, probably my x is equals to what? T. So no difference there. It's like saying f of what? Of t is equals to what? T. Let me say that I'm having my n here, right? So if I should differentiate this, I'm differentiating x with respect to what? To t. So it will be what? The x all over what? The t. And that will give me, once I bring my n down, I must subtract 1 from my n, right? So similarly, the same thing will apply here. So I'll just put a prime here, right? Now, let's take an illustration. Now we'll be focusing on this formula here that we have here, and we'll see what will happen. So example 1. Example. Now let's take this for instance. What about let's take this case 1. Case 1 here. Now, what about this? Y equals to what? X. Y equals to x. Now, looking at it this way doesn't mean there is nothing here. We say it's power rule. Now, you ask yourself the question, what is the power of x here? We know the power of x here is 1. This is not written, so it is 1. So, similarly, it means that my dy all over what? The x is equals to Once I write my x down, the power will come down. Then I'm going to subtract 1 from it. And this will now give me the y. This will now give me 1 times anything will give you that thing, right? So we'll be left with what? X to the power of what? 0, because 1 minus 1 is 0 times the 1 here, right? So this will give me 1 times what? Times 1, because x's power 0 is 1. So my answer is what? Is 1. Now, if I do the same thing, number 2, this is example 1. Now, for example 2, if I have y equals to what? X, let me use the value of what? Cube. That is x to the power of 3. Then this will be, once I write my dy all over what? The x, it will be, I'm going to write back my x cube. I'll take the power here, we'll call it power row, come to the front, right? Then I'll subtract 1. Once it comes down, once I do the y over the x, that means the output over the input, I must bring the power down, and I'm going to what? Multiply and subtract it from 1. Subtract 1 from it. And this will give me 3. So 3 minus 1 is 2, so we have 3x to the power of what? 2. Let's take another example. Number 3. What about if I have y is equals to what? 4x cube. Similarly, it means that once I place my dy all over what? The x. So it means that I'm only focusing on the variable, not the constant. So you focus on the power of the variable. So I'll just write it back, my 4x cube, right? So since I put the y over the x, the 3 will come down to multiply the 4. Because the 3 has come down, I'm going to subtract 1 from the 3. And this will give me 3 times 4 is what? 12. Then we have x raised power what? 2. So that will be my answer there. That is for this case. Now, case 2. I'm moving forward. For case 2, we'll be dealing with fraction. That will be for example 4. I can use any value of my choice. I can say x is equals to what? 2 all over what? All over t. Now the keyword is you focus on the variable of the right hand side. Now this will be, I can rewrite this again by saying x is equals to 2 multiplied by what? 1 all over what? T. And we know very well that this 1 over t, when it's another way of writing it, means that the inverse of what? Of t. That means my x is equals to 2 multiplied by what? T inverse. T is power minus 1, because the t here has a power of 1. When it's everything is coming up, you put negative to the power. Now, that means if it is 2, that we have here to be this power minus 2. If it is 3, it means this power minus 3. If you look at this very well, once I've placed my dx all over what? The t, because I'm differentiating x with respect to what? T. This will give me, I'm focusing on the variable and the power here. So my 2, I'll just write it this way, my 2 t to the power of what? Minus 1, since I'm saying 2 times t is power minus 1, right? So the minus 1 will come in front of it to multiply the 2, then I'll subtract 1 from it. Once it comes down, you subtract 1 from it, right? So this will now give me minus 1 times 2 give you minus 2, then t minus 1 will give you minus 2. So we are going to be having this way. This will now give me minus 2 all over what? T squared. Once this t raised power minus 2 is coming down, the minus will what? Disappear. Now let's see another condition here. For example 5, if I have the same x equals to what? T all over what? 2. You see now I've changed it. What will I do? I am going to say that my x is the same thing as t multiplied by 1 over 2. I'm subtracting the numerator from the denominator. This is how I write it, right? Now, we're focusing on the variable. The variable is just there, but the power of the variable is what? Is 1. So I'm going to say that my x, my dx, all over what? Dt will give me, I'll write it out, t raised to power 1 multiplied by 1 all over 2, right? So when the 1 come down to multiply the t, I'll subtract 1 from the power. And this will give me 1 times will give me t squared multiplied by 1 all over 2, right? And this is the same thing by saying t squared all over what? 2, right? So from here, so that's in terms of fraction. It can be in any way, right? So let's move further to case 3. For case 3, we'll be talking about roots, variable associated with what? Roots. So if I have my y equals to what? The root of what? Of x, right? Whatever we are doing, we must ensure that the variable is always at this form of writing x to the power of what? Of n. That's what we should be after. Now with the knowledge of your differentiation, your indices, another way of writing it, because root means 2, square root means 2, right? And there's a 1 on top of here. This the power of this variable is 1. So another way of writing this is what? Y is equals to x 1 all over 2, right? x1 over 2. So from here is now in this form already. So I can easily access my power. In this way I cannot access my power, but in this way I can easily access the power. So from here I will now say that my dy all over what? Dx will give me, I'll write it out, the same criteria, 1 all over 2. Once this guy comes down, 1 over 2, I'm going to subtract 1 from it, right? So from here, this will now be 1 all over 2 multiplied by what? X minus 1 over 2, because half minus 1 will give you minus half. Now if I want to eradicate this negative sign, I'm going to write it as saying 1 all over 2 multiplied by what? 1 all over what? X 1 over 2. Now if you look at this is the same thing by writing 1 times 1 is 1 all over 2 times will give me 2x 1 all over 2. which is the same thing by writing it as saying 1 all over what? I can put it this way, by writing as saying 1 all over what? 2 root x, because x raised by 1 over this as saying root x. So that is my answer here. Now, what about if I now write it like this by saying, let me use something else, saying v, let me say v is equals to the let me put it cube root of t squared. Now, first of all, take it to this form so that you'll be able to access the power. So this will give me my v will now be t the power all over whatever is inside this root, 2 over 3, right? So since I can access the power now, this will give me the v all over what? The t equals to what? T 2 over 3. Since I've written this way, the power will come down. I'll be having 2 all over 3 multiplied by that, so minus 1. So this will now give me 2 all over 3 multiplied by t. If you look for the LCM, that means having 2 over 3 minus 1. The LCM here is what? 3. 3 in 3 is 1. Then we have 2 minus what? 3. So that gives me minus 1 over what? Over 3. Right? So from here, I'll be having minus 1 over 3. Now, if you now want to put this very well, this will be like saying 2 all over 3 multiplied by, if I change this inverse, it will be 1 over what? T1 over 3, once I want to remove the minus sign. So from here, 2 times 1 is what? 2. Then 3 will give you 3t1 over 3. Either you leave it this way, or you say 2 all over what? 3, the cube root of what? T. Any of the two is correct. So that is in terms of what? In terms of root. So, and some things you need to understand as we move along is that there are some functions you need to know. If I say my y is what? Is cos x, right? So the derivative of y will be what? Minus sine x. And also, if I have sine x, derivative of sine x will give you what? Cos x. So, also, if I have ex, it will also give me ex. If I have ln x, it will give me 1 over x. Either you call it ln x or you say natural log of what? Of x. Right? Any of the two. Any of these two. Now, if I have tan x, you'll be having sec square x. If I'm having sec x, you'll be having sec x tan x. If I'm having cot x, you'll be having minus cosec square x. And if I differentiate any constant at all, a constant, right? Maybe 1, 2, I'll be having what? 0. Right? And we know very well that if you have xn, you'll be having n x n minus 1. So these are some of the common functions you need to just know in your head. We have proven for this, but you just know this. As we move higher in the course, we will expose you to more of this function. So if this video has been helpful to you, don't forget to click on the subscribe button. Thanks for watching.